In this graph, we're going to look at how you can sketch the derivative of a function from the function itself. Before we start, I want you to remember one sentence. The slope of f of x is the y value of f dash of x. Here we're given a graph f of x. It just happens to be a cubic. So let's go and put in what we actually know about the graph. We know that at this point, the gradient of the graph is 0, and there is a maximum. We also know that at this point, the gradient of the graph is 0, but we have a minimum. So just at this side of the maximum, the gradient is very slightly positive. At this side, it is very slightly negative. Now let's go to the minimum. So at this side, it's very slightly negative. At this side, it's very slightly positive. Up here, it's very positive. And over here, it is very positive. So as we go up, positive, 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 but it's getting less and less and less positive until it gets to 0. Then it becomes negative, slightly negative, slightly, 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 till here it becomes its most negative. Then it becomes less negative, less, 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 until we get to 0. Then it goes back to positive, a little, a little, a little, a little. As we go up, it gets more and more positive, more and more positive, until we get there. So because at these points we have a maximum and a minimum, we know that the gradient is 0, so I'm going to put that on. So that is a gradient 0. We've got a gradient of 0 there. And between those 2 points, it is always negative. And at this point, it is its most negative. So I know my graph is going to turn at that point and always be negative between those 2 points. To the left of this point, my graph or gradient is positive. Again, at this side, I know my gradient is positive. So there we have the graph of f dash x. This time we're going to be sketching the graph of f of x from the graph of f dash of x. So we're going to be graphing the original function from its derivative function. If you look at the graph, I've given you exactly the same graph, but this time it's the graph of f dash of x, its derivative. Before we start, I'd just like to point something out. If I've got the function 6x cubed minus 10 and 6x cubed plus 10,000, they are both, those functions are going to give us exactly the same derivative graph. But there's a vertical shift of 10,010 units upwards. So when you're drawing the original graph, you can't be sure exactly where on the page, on your set of axes, the actual graph is going to be because of this vertical shift that you don't know about. So let's first start putting in exactly what we do know about our graph. Well, here we have a turning point because the gradient is 0. And at this point, our gradient is going from negative to 0, and then it becomes positive. So we have a minimum point. So at this point, we have a minimum. I don't know where it is, but I'm going to put it in. So I have some minimum point there. Here, I have a turning point. This time, it's going from positive 0 to negative. So I have a maximum. So there I have a maximum point. I don't know exactly where it is, but I'll put it there. And again, here I have a minimum because it's going from negative to 0 to positive. So I'm going to put some minimum value there. I've also got two other points that I need to be aware of. I've got one here where the gradient, because remember this is our gradient graph, is 0. And where the gradient is 0 indicates that we have a point of inflection. That means the concavity changes from positive to negative or negative to positive. So halfway between the two, so we've got a point of inflection there. Again, between the other two, we also have a point of inflection. So there's a point of inflection maybe there. So now we can draw in our graph. So that's the first point. Comes back up here, and remember it goes on forever. Now it's going to come down here, keep going down to there, and then back up here forever. So that is our graph of f of x. And remember, it might not be in that exact position because there might be a massive vertical shift because of some constant at the end of our graph that we don't know about. One last thing I'd like to point out is if you start with f of x and it is a cubic, your f dash of x, or your derivative graph, will be a quadratic or some parabola. If you then differentiate it for a second time and get the second derivative, you will end up with a linear graph. And vice versa, if you start off with the second derivative and it's a straight line, you will end up with the first derivative graph being a quadratic. And then if you go up again, the original graph will be a cubic.